Now we will discuss the main part of this chapter, and that we call as the heart of that chapter. This concept, that is the study of vibration of air columns, it can be said to be the heart of this chapter. Therefore, just we are going to write down that. Now what happens? Again, generally we know that the body, it is going to vibrate with its natural frequency or the forced frequency. Later on we are going to see what is that natural frequency and forced frequency. But one must know that whenever the body vibrates with its own natural force and the frequency, then it is a natural one. We are going to study the vibrations of air column. It means that there must be a closed pipe or the pipe which is open, and the air column, it is going to vibrate within that given part and given boundary. There is the limitation. That means if we have the pipes, suppose that there are two pipes, they are given, and it can be seen that this one end, it is closed, whereas in second case there are the open ends or openings are given at both ends, and hence we are going to study the vibrations of air column in these two cases. What happens? Firstly, we are going to see the case first. The case first is that see this, the modes of vibrations in a pipe closed at one end. By saying this, one can say that the pipe which is given, organ pipe which is given, and it is open at one end and closed at one end. Let us see what happens. Whenever the sound waves, they are going to travel, within this pipe which is closed at one end. This is the organ pipe. Generally it is a cylindrical pipe having a small diameter near about 3 centimeter. It is having the diameter, and it is a uniform flow. Just we are going to say that it is a pipe. This organ pipe, it is cylindrical in shape, and therefore what happens, whenever we are going to use that for the experiments, generally it is used for resonance tube experiment, in which we are going to find that the velocity of sound in that pipe at room temperature. Suppose if we are going to take a tuning fork is given, and it is held exactly parallel to that portion, like that, and the vibrations, they are going inside that pipe. Taking that tuning fork, it is gently hit on that rubber pad, and the vibrations, these vibrations, they are going in that pipe closed at one end. Again, what happens, as the vibrations, that is longitudinal wave, they are going to travel within that portion within that portion. So what happens? The wave is the incident wave which is traveling inside that pipe. This is incident wave, and there is a reflected wave. So what happens? The boundary conditions must be satisfied. What is boundary condition? The nodes must be formed as at closed end, whereas antinodes must be formed at open end. Openings, it means that there is much more freeness of the particles of medium. Therefore, the boundary condition is going to satisfy. There is a node and there is a antinode. Open end contains antinode, closed end contains node. Now what happens? Again, we are going to see. This is the part. Suppose that an antinode is formed at open end. Antinode is formed at open end. It travels within the length of pipe, incident at the closed end, reflected back and goes to that of opening. It means that when antinode is inserted in the pipe, it is reflected as a node. It is going to reflect as a node. And therefore, if we are going to consider the length of pipe, suppose that this is the length of pipe which is having value is equal to L, and we are going to consider this much of the part within that wavelength or the wave. Just we are drawing a figure for our sake of convenience. This is lambda. This part which is contained within that column is that. In this column, we are going to see this part is related with this part, that is a node and an antinode, and it is having values equal to lambda by 4. Therefore, in the first case or the possible case where the boundary conditions are going to satisfy, that is antinode is formed at open end and node is formed at closed end. Therefore, this wavelength is equal to lambda by 4. This part contains a wavelength that is equal to lambda by 4. And if the value of time period, if we are going to consider the time period for that particular part, time period, the value of time period can be given as T by 2 is equal to twice L divided by V. Now what is that relation? It means that this T by 2, it is the time required to produce an antinode to node and again that of antinode. It means that the wave is traveling through this part and it requires a time period T by 2. And whereas this distance is equal to, that value is equal to twice L divided by V. Just one must know that it is equal to twice the length of that pipe, that 2L. How much distance is travelled by the wave? From this point to this point, that is L, and again from this point to this point, that is L. Therefore, we are going to take that value twice L. But this distance, this is the distance. How it is? Velocity is equal equal to distance upon time. This is the formula, and we need that distance. Therefore, distance is equal to no, that is not one. Time period t by 2, and the distance traveled is twice L with velocity v. And therefore, this formula is like that: v is equal to this 2 is multiplied 4L divided by t. Just we are going to cross multiply that. After cross multiplying that, this is equal to n. Therefore, v is equal to 4 n L. So v is equal to 4 n L. That is the equation number 1. What happens in this case? In this case, these are two time periods. One must know that the two time periods. This is the time period for traveling through that air column, and this is the time period for the velocity to travel that column. Therefore, we are going to take this formula, and finally we have that velocity of sound in air column. This is the natural frequency in that pipe open at one end, closed at one end. It is going to vibrate with number of modes, and these frequencies are called as natural frequencies. But what happens? This is the most lowest frequency with which this air column is going to vibrate. Therefore, this is the fundamental mode, and therefore this is called as fundamental frequency. V is equal to 4nL. This is the fundamental frequency with which that air column is going to vibrate. Therefore, we are going to say that this is the first mode of vibration. Mode first. In first mode of vibration, again, we are going to see that if this value is there, L is equal to lambda by 4. L is equal to lambda by 4, and therefore lambda is equal to 4L. Velocity, therefore velocity V is equal to n lambda. Putting the value of lambda, that is 4 n L, exactly similar to that of equation 1. In first mode of vibration, can be seen that the length of pipe is L. The wave which is contained within that pipe is lambda by 4. Therefore, in first mode of vibration, the velocity of sound is going to be V is equal to 4nL. This is the most probable, lowest probable frequency with which the pipe which is closed at one end is going to vibrate. Therefore, this frequency V is equal to 4nL is called fundamental frequency. We are going to draw the figure for second mode of vibration. For second mode of vibration, again there is no change in length of the pipe. The length of pipe is going to remain same. But what is going to change? The wave which is containing in that column, that air column having different wavelength. It means that the sound waves which are traveling within that pipe, they are going to be different, because again the boundary conditions must be satisfied. What is that boundary condition? Node must be formed at closed end and antinode is formed at open end. See that. One is the incident wave, one is the reflected wave. Node is formed. There is antinode, again node and antinode. Boundary condition is satisfied, that is node is formed at closed end and antinode is formed at open end, and the L remains the same. So if we are going to compare with wavelength, we are going to consider that part with this wavelength. This is lambda again. The part which contains one loop and half loop, that is this one loop and half loop. There is. It means that it is the 75% of that wavelength. It means the value is going to be, in terms of wavelength, is 3 lambda by 4. And as it is different mode of vibration, therefore we are going to put lambda 1. This is the second mode. Mode second. In second mode of vibration, the air column is going to vibrate like this, putting the values. L is equal to 3 lambda 1 divided by 4. Therefore, the value of lambda 1 is equal to 4L divided by 3. Putting this value in our equation, the velocity of sound V is equal to n lambda 1. We are going to take different velocity and that different frequency n1 into lambda 1. Putting that value lambda 1 n1. Sorry, it must be n lambda. Putting the value of lambda 4L divided by 3. And therefore, we need that value n is equal to, that is right one, n1 is equal to 3 V divided by, this is multiplied here, 3V divided by 4L. In fundamental mode, the value of n is equal to, as V is equal to 4NL. Therefore, n is equal to V divided by 4L. That is the value of frequency. Just substituting that value, it means that this value is going to be replaced by that n. Therefore, n1 is equal to price of n. This is the first mode, this is the second mode, and just we are going to see the third mode. Mode third. Again, there is no change in length of pipe. Length of pipe is going to remain same. But what is going to change? The wave which is within that pipe. The wave which is within that pipe, it is going to change. Therefore, what must happen? Boundary conditions must be satisfied. A node is formed and antinode is formed at open end, like that. One, two, and 3. The next part is that must contain 2 loops only. The next part of that must have 2 loops only. 2 loops like that. 1, 2, and up. That one is the correct. Now how one can draw these figures or the wavelength within that pipe? Just we are going to remember that see, we are going to apply this wavelength within that pipe. Boundary conditions must be satisfied. Node is formed at closed end. Node is formed at closed end. Antinode must be formed at open end. Antinode must be formed at open end. This is the first part. This is the fundamental node. Again, using that wave, a node is formed at closed end. There is node. And antinode must be formed. This antinode, it is within that first node, therefore we are not going to use that. This is node and this is the antinode. It means that the second part contains up to this point. This is this part within that air column. Now what happens? The next part. What is that next part? Node must be formed. Node is formed. This antinode, this antinode, this antinode, and this antinode. Two antinodes are there. One and two, the antinodes. And we are going to use that node because this open end must have antinode. It means that it is this part and must like that. Means two loops and half or the 1/4 of that loop. See, node is formed, node, antinode, node, antinode, node, and antinode. L remains the same. That is, length is going to remain same, and we are going to see that what is the wavelength, the value of wavelength. Now we are going to apply the wavelength. This is the full length, lambda, and this 1/4 portion. This 1/4 portion is added within it. Therefore, must be 1.25 like that. Lambda 2 must be 5 lambda by 2 divided by 4. Using that 3 lambda by 1 divided by 4. This is lambda by 4. Just applying the values in terms of percentage. 1 divided by 4 is 0.25 multiplied by 100, that is 25%. This is 25%. 3 by 4, it is 0.75. 0.75 multiplied by 100, that is 75. 5 divided by 4, 1.25 multiplied by 100, but in percentage, that is 125. It means that in case of percentage, the values can be remembered. If one must not remembering these values, then must remember like this: 25%, 75%, 125%, and the next is adding again 50. It means that 175%. Again adding 50, 225%, like that. Therefore, in that case, what happens? Formula is what is that formula? Lambda is equal to 5 lambda by 2. Sorry, L is equal to 5 lambda by 2 divided by 4. Therefore, the value lambda 2 is equal to 4L divided by 5. The value of lambda. V is equal to n lambda. N2 lambda 2. Putting the values. We want, therefore, n2 is equal to V divided by lambda 2. Putting the value of lambda 2 is equal to 4L divided by 5, which is in denominator comes to numerator, and again this value, it is going to replace by, it is going to replace by that small n, and the formula becomes like this. N2 is equal to 5N. Now see that what happens if you are going to take the relation for N, N1, N2 and N3. Number of frequencies. They are like what? N, 3N and 5N. This is 5N, this is 3N and this is N. The relation is like that. Finally, we are going to conclude that. What is conclusion? There is a conclusion. Harmonics are present, but these harmonics are odd harmonics, and therefore the overtones which are present in this pipe are odd harmonics. Again, remember that what is the harmonics and overtones. Harmonics means the pipe or the anything which contains the whole numbers. This pipe, if it is containing all frequencies, then it is a harmonic. But the actual ones are N, 3, 1, 5 N, they are going to present within that. Therefore, they are called as overtones. These are the overtones. Just again, the example for overtones and harmonics is like that. Suppose that number of students they are present in our class from roll number 1 to roll number 100. The students which are on our attendance sheet, the number of students which are on our attendance sheet are 1 to 100. It means that they are the harmonics. But the number of students which are present in the class, it means that roll number 1 is present, 2 is present, 3 is not present, 4 is present, 5 is present, 6 is not present. Therefore, the students which are exactly in that classroom, they are the overtones which are actually there, they are present. But the total number of students are 100 and the present number of students are 60. 60 number of students they are present in the class. Therefore, 1 to 100 they are the harmonics. There are the number of names, number of students, that is 100. They are the harmonics. But who are actually present in the classroom, some 60 students they are present in the classroom, they are called as overtones. That is the concept of harmonics and overtones. Number of frequencies they are present within that air columns, they are the harmonics. But the actual ones which are present within that columns, they are the overtones. Therefore, the pipe closed at one end, it contains odd harmonics as overtones, or the overtones are present as odd harmonics. Therefore, this is the first frequency, which is the fundamental frequency. Next higher frequency is called overtone. This is the first overtone. This is next frequency is second overtone. But in case of harmonics, if you are going to consider harmonic, this is the first harmonic. 2N is not present, but that is the second harmonic. This is third harmonic. 4N is not present, but still we are going to count that. And this is fifth harmonic. Now see that the first overtone is third harmonic and second overtone is fifth harmonic, because we are going to count the frequencies which are not present, which are included in harmonics. But in case of overtones, what happens? We have to take only those frequencies which are actually present at there. Therefore, N is present, 3N is present, and 5N is present. Again, the question is that why we should not use that N as overtone? The first frequency, most lowest frequency, is the fundamental frequency, and it is first harmonic. Next to that, other than that fundamental frequency, the next higher frequency is overtone. That is first overtone. That is the difference. Therefore, in general, we can write down the frequency of nth peak overtone can be given as frequency. Just we have written that frequency. Formula for that frequency is that. What is that? N is equal to V divided by 4N. But what happens in this case? There are only odd multiples are there, odd frequencies they are going to present. It means that N is this value, then this is 2p plus 1 into V divided by 4. This is the formula. Where P is equal to 0, 1, 2, 3. Let us see if this happens to that. P is equal to 0. P is equal to 0, it is V divided by 4N, that is N. Correct one. Putting the value 1, 2 into 1 is 2, 2 plus 1, 3. 3V divided by 4N, taking this value is N, 3N. That one is also correct. Taking the value is 3. Sorry, taking the value 2. 2 into 2, 4, 4 plus 1, 5. 5V divided by 4N. Putting this value is equal to N, that is 5N. That is also correct one. Therefore, this is the generalized formula for calculating the frequency. The second part is that modes of vibrations in pipe, open at both ends. This is the second case in which we are going to study the different modes of vibration. Again, there are number of modes of vibration, but still we are going to use only 3 parts, and using that 3 parts we are going to generalize that formula. Therefore, using the first mode, for that boundary conditions must be satisfied. Again, in that what happens? Look at that, boundary condition is satisfied, antinode is formed at open end, and at closed end there must be the formation of nodes.